Good morning to all of you. In previous session, we have seen how to identify the total solution of the difference equation. We have seen the total solution of the first order difference equation. We identified homogeneous solution, zero input response, particular solution. From homogeneous solution and particular solution, we identified the zero state response, and then the total response of the system is represented as the zero input response plus zero state response. Okay. Today we will also see while identifying the homogeneous solution as well as particular solution, you should avoid the redundant terms. Okay, if there are redundant terms in the homogeneous solution or the same term is present in the particular solution, so you should avoid it, right? So that same term should not be there. Okay, otherwise you will not get the values of constants properly. Okay, so that will also be discussed in today's session. Okay, we will be looking at one of the example of identifying the total solution of the second order difference equation. Okay, in today's session. So here is the example. Here again you have to determine the response. Okay, whenever the response has been asked, right, we have seen that if in example or problem it has been asked that to determine the response or to identify the response, then you can use convolution summation. Okay, but when you are using convolution summation, you will be provided with the input signal and the impulse response, right? But in this case the difference equation is given, right? So to identify the response of the system, you have to solve this difference equation, and you have to identify the zero input response, zero state response, and then combine it to get the total response of the system represented as y of n. Okay, so that means here you will be identifying the initially the total solution of the given difference equation, and then from that total solution you will be identifying zero state response. From homogeneous solution, you will be identifying zero input response. Combining zero input response and zero state response, you will get the total response of the system. Okay, so it is the second order difference equation, right? And the input sequence is given as x of n is equals to 4 raised to the power n u of n. Okay, so again you will write the given difference equation is that y of n minus 3 y of n minus 1 minus 4 y of n minus 2 is equals to x of n plus 2x of n minus 1. Okay, so initially you need to identify the homogeneous solution from the given difference equation. Okay, and the given input x of n is equals to 4 raised to the power n u of n. Okay, so to identify, call this equation as first equation, to identify the homogeneous solution, input x of n is equals to 0, right? So you have to assume input x of n is equals to 0, right? So and the homogeneous solution, okay, that is yh of n has the form lambda to the power n. Okay, so and homogeneous solution has the form, okay, yh of n is equals to lambda to the power n. Okay, so you will represent this given input output equation. So first equation will be simply represented as y of n minus 3 y of n minus 1 minus 4 y of n minus 2 is equals to 0. Okay, so there are two input terms on the right hand side, x of n and x of n minus 1. Okay, so both will be considered as 0 for identifying the homogeneous solution. Okay, you can consider this as equation 2, right? And to get the homogeneous solution, again you have to substitute in this equation. In place of y of n, you will substitute lambda to the power n, because the homogeneous solution has this form, that is yh of n is equals to lambda to the power n. Okay, so it will be simply lambda to the power n minus 3 lambda to the power n minus 1 minus 4 lambda to the power n minus 2 is equals to 0. Okay, so from this equation you can take lambda to the power n minus 2 common, right? So if I am taking lambda to the power n minus 2 common from the equation, so in bracket what I will get lambda square minus 3 lambda minus 4 is equals to 0. Okay, that means simply if I am sending this lambda to the power n minus 2 on the right hand side, so it will be 0 divided by lambda to the power n minus 2, so it will be 0 simply. Okay, so the remaining polynomial lambda square 3 lambda minus 4 is equals to 0. So if you solve this polynomial, so you will get two roots, correct? So this will be simply lambda minus 4 and lambda plus 1, right, is equals to 0, right? So the lambda will have two values, that is lambda is equals to 4 or what, minus 1, right? So these are the two roots that you get here, right? So therefore the homogeneous solution, right, yh of n, as there are two roots, so you will be considering two constant, that is c1, first root is represented as lambda 1 to the power n plus c2 lambda 2 to the power n. Okay, and we have these values yh of n is equals to, so we have identified two values, that is 4 and minus 1. So simply here you can write c1 4 raised to the power n plus c2 minus 1 raised to the power n. Okay, so this is the required homogeneous solution. Okay, so from this homogeneous solution you have to identify the zero input response. Okay, so for identifying again zero input response, you need to identify the values of these constants c1 and c2. So as there are two constants, so you will be substituting two values of n in the equations, uh, equation 2 and equation 3, correct? So you will be substituting n is equals to 0 and n is equals to equation, sorry, n is equals to 1 in equation 2 and equation 3, right? So for identifying zero input response, put n is equals to 0 and n is equals to 1. Okay, in equation 2 and equation 3, right? Why we are using equation 2? Because we are identifying the zero input response. Okay, so while identifying zero input response, these inputs will be considered as 0, right? So therefore we are using this second equation. Okay, so to identify for identifying zero input response, we are substituting n is equals to 0 and n is equals to 1 in second and third equation, right? So your second equation will be simply, it is given equation, so it is what is that, y of n minus 3 y of n minus 1 minus 4 y of n minus 2. So if I am substituting n is equals to 0, so I will get y of 0, right, y of 0 minus 3 y of minus 1, right, minus 4 y of minus 2 is equals to 0, right? So that means the value of y of 0 will be equals to 3 y of minus 1 plus 4 y of minus 2. Okay, so I'll call this equation as A, right? Similarly, I will substitute n is equals to 1 in the same equation, so I'll get y of 1 minus 3 y of 0 minus 4 y of minus 1, right? So it will be y of 1 minus 3 y of 0 minus 4 y of minus 1 I will get. Okay, is equals to 0. So again y of 1 is equals to 3 y of 0 plus 4y of minus 1. Okay, so in place of this y of 0 I can substitute this value, right? That is 3y of minus 1 minus, sorry, plus 4y of minus 2. In place of y of 0 I can substitute that value. So I will get simply, so 3 will get multiplied with 3, so 9 of minus 1, right? 3 multiplied by 4 plus 12 of minus 2, right? Plus this remaining term, that is 4 of minus 1. So finally the equation for y of 1 will be, so this 9 plus 4, that will be 13 y of minus 1 plus 12 y of minus 2. Okay, I'll call it this as equation B. Similarly, I have to substitute n is equals to 0 and n is equals to 1 in third equation, right, in this equation. So what I'll get, so if I'm substituting n is equals to 0, so I'll get yh of 0 is equals to c1. So it will be 4 raised to the power 0 will be 1, so it will be simply c1, and this will be c2 minus 1 raised to the power 0, right? So it will be simply again 1, minus 1 to the power 0 will be again 1, right? So it will be c1 plus c2 simply, right? So it will be c1 plus c2. So this can be indicated as equation C. Similarly, I can substitute n is equals to 1 there. So yh of 1 will be equals to, this will be 4 raised to power 1, so it will be 4c1. Okay, so I'll get 4c1, and minus 1 to the power 1 will be minus 1, so it will be minus c2. So minus c2. So this will be equation D, right? So to get the values of c1 and c2, I have to equate c with a and d with b, right? So to get values of c1 and c2, equate equation c and equation c with equation a, right, and equation d with equation b, right? So what I will get here when I am equating c with a, so it will be c1 plus c2 is equals to 3y of minus 1 plus 4y of minus 2, right? So c1 plus c2 is equals to 3y of minus 1 plus 4y of minus 2. Okay, so basically this procedure we have already seen, but as in the given example we have to identify the total response. So initially you need to identify the homogeneous solution, from that you can identify zero input response. So we are trying to identify zero input response here, right? So next we have to equate this d with b, so 4c1 minus c2, so that is 4c1 minus c2 is equals to that 13y of minus 1 plus 12y of minus 2. So 13y of minus 1 plus 12y of minus 2. Okay, so here you will be simply adding these two equations. So if I am adding this, so this c2 minus c2 will be 0, so it will be c1 plus 4c1 will be 5c1 is equals to 16y of minus 1 plus 16y of minus 2, right? So that is the value of what you can get the value of c1 from this equation simply as what, I have to simply transfer this 5 on the right hand side, so you will get this c1 simply so you will get the value of c1 as 16 by 5 y of minus 1 plus 16 by 5 y of minus 2. Okay, so this will be the value of c1, right? Next you can substitute this value in any one of these two equations to get the value of c2. Okay, so just for example, if I'm substituting this value in this equation, Okay, so what I will get, so simply directly write C2 is equals to, I'm sending these values on the right hand side. Okay, because in place of C1 I will be substituting 16 by 5 y of minus 1 plus 16 by 5 y of minus 2. So if I'm sending these values on the right hand side, it will be minus 16 by 5, right, y of minus 1. So this plus 3y of minus 1 will be as it is. Okay, next one is, again this will be sent on right hand side, so this will be 16 by 5 y of minus 2 plus 4y of minus 2. Okay, so if I solve this, so I will get minus 1 by 5 y of minus 1. Right. Similarly here also I will get plus 4 by 5 y of minus 2. Right. So this is the required value of C2. Right. Now these two values I can substitute in this homogeneous solution, and then I will call it as the zero input response. In place of C1, C2, I can substitute these two values. Right? So put C1 and C2 in equation what is that equation 3. Okay, so that will be called as now zero input response yz of n. Okay, so what is that, C1 multiplied by 4 raised to the power n. Okay, so what is the value of C1? So it will be 16 by 5 y of minus 1, right, plus 16 by 5 y of minus 2 into 4 raised to the power n, plus in bracket minus 1 by 5 of minus 1 plus 4 by 5 of minus 2, right, multiplied by minus 1 to the power n, minus 1 to the power n. Okay, so this is what the required zero input response, right. Okay, so this is required zero input response. So next step is to identify the particular solution. Okay, so for identifying the particular solution, again the particular solution has the form, what form it has, so it will be simply yp of n is equals to constant into input. Okay, so if I'm substituting the value of x of n in this particular solution, so what is x of n given? So x of n is given as 4 raised to the power n into u of n. Okay, so I can substitute here 4 raised to the power n u of n, right. So before proceeding, right, in every problem you have to compare this particular solution with the homogeneous solution. Okay, so this is your homogeneous solution. Okay, comprising constant multiplied by 4 raised to the power n. Okay, as you are identifying it for n greater than or equals to 0, right, this equation is also valid for n greater than or equals to 0, right. So this homogeneous solution and the particular solution, because again this will be for n greater than or equals to 0, because this u of n will be 0 for negative values of n, right. So it comprises constant multiplied by 4 raised to the power n. Even this homogeneous solution comprises constant multiplied by 4 raised to the power n. So that means homogeneous solution and particular solution has the redundant term. Okay, so you have to compare this point, you have to note down, you have to compare homogeneous solution and particular solution. Okay, and if there is any redundant term, so you should avoid that redundant term, uh, so that the same term should not exist in the homogeneous solution and the particular solution. Okay, so as we compare homogeneous solution h of n and particular solution, that is yp of n, we observe that yp of n, okay, that means yp of n comprising this term, that is constant multiplied by 4 raised to power n, is already contained in the homogeneous solution, right? So we observe that yp of n is already contained in the homogeneous solution. Okay, this yp of n constant multiplied by 4 raised to the power n is already contained in the homogeneous solution, constant multiplied by 4 raised to the power. So this is nothing but the yp of n. Okay, so the particular solution is redundant, right? We have to avoid this redundant solution. Okay, so for avoiding it, select the particular solution to be linearly independent of the terms contained in the homogeneous solution. Okay, so we have to modify this particular solution. Okay, simply you have to say that here, so we will be modifying this particular solution, right? So you have to select the particular solution such that it will be linearly independent in respect respective to the homogeneous solution, right? So simply we'll modify the particular solution as we'll assume the particular solution as yp of n is equals to k multiplied by, we'll simply multiply this particular solution with time variable, okay, that is small n. Okay, the remaining term will be as it is 4 raised to power n into u of n. So as you can see, if you compare now this with the homogeneous solution, so this term, that is constant multiplied by time multiplied by 4 raised to power n, will be different than the constant multiplied by 4 raised to the power n, because the value of this term depends on time. Okay, that is small n. Okay, so you have to substitute this, substitute yp of n in equation 1. Okay, that is in the given input output difference equation. This equation you have to substitute it, and while substituting you have to substitute the values of x of n as 4 raised to power n u of n plus 2 into 4 raised to power n minus 1 u of n minus 1, while in place of y of n minus 1, y of n minus 2, you will substitute these values, that is k into n into 4 raised to power n u of n. Okay, so in place of y of n, you will substitute simply your first equation will be in y of n, you will substitute this value, that is k into n 4 raised to power n u of n, right? In place of 3 y of n minus 1, okay, so minus 3y of n minus 1 is there. So 3k n minus 1 into 4 raised to power n minus 1 u of n minus 1 will be there, right? Similarly, next term is minus 4y of n minus 2, right? So minus 4y of n minus 2 is there. So in place of y of n minus 2, again k n minus 2. Okay, so we are substituting this value. So in place of n minus 2 will be there. 4 raised to power n minus 2 u of n minus 2 will be there, is equals to, as we are trying to identify particular solution, so we will not be considering input 0. So input will be there. So input is here x of n, but the value of x of n is 4 raised to power n u of n. So I will be substituting 4 raised to power n u of n here, right? Plus similarly that plus 2 into x of n minus 1. Okay, so again the value of x of n minus 1 will be 4 raised to power n minus 1 u of n minus 1. So it will be simply 2 into 4 raised to power n minus 1 u of n minus 1, right? So again you have to determine the value of k here. Okay, but for determining the value of k, you have to substitute value of n such that every term in this equation should exist, right? So I can substitute n is equals to 2 here, right? Because u of 2 minus 2 will be 0, right? Even I can substitute n is equals to 3, right? You will get same value if you are substituting any value of n greater than or equals to 2. Okay, so I'll say to determine value of k, put any value of n greater than or equals to 2 in above equation, right? Okay, so why we are substituting n is equals to 2 or greater than 2? Because every term should exist. If I'm substituting n is equals to 1, so this u of 1 minus 2 will be u of minus 1, and u of minus 1 is 0, so this term will be 0, right? So therefore I can substitute when n is equals to 2 or n is equals to 3 or any value greater than or equals to 2. Okay, so if I'm substituting n is equals to 2 in this equation, right, so what I will get, so it will be simply 2 multiplied by 4 square, so 16. So you will get 16 multiplied by 2, right? Because the value of n is equals to 2 I am substituting, so 2 multiplied by 16, right? I will get that, right? Similarly, so just I will substitute these values in this equation. So here I will represent k multiplied by 2 multiplied by 4 square, right? Because I am substituting n is equals to 2. Okay, so for n is equals to 2, right? Okay, so u of 2 I will get there, right? So u of 2 minus, so minus 3k 2 minus 1, 3k 2 minus 1 multiplied by 4 raised to power 2 minus 1, 4 raised to power 2 minus 1 u of 2 minus 1, right? Minus 4k minus 4k is that 2 minus 2 will be there, right? 2 minus 2, then 4 raised to power 2 minus 2 u of 2 minus 2, right? U of 2 minus 2, right, is equals to again 4 square u of 2, right? 4 square u of 2 plus 2 into 4 raised to power 2 minus 1 u of 2 minus 1. So here 2 multiplied by 4 raised to power 2 minus 1, right, u of 2 minus 1, right? So if you solve this, so it will be simply 4 square, right? So 16 multiplied by 2, that is 32k, right? U of 2 is 1 minus, so this is 3 multiplied by 1 multiplied by 4. Okay, so it will be simply 12k, right? Because u of 2 minus 1 will be u of 1, u of 1 is 1, right? So again this 2 minus 2 is 0, so this term will be 0, right? If you are substituting n is equals to 3, you will get the same value of k what we will be getting here, right? Okay, so next it will be 4 square, that will be 16, right? So 16 plus this will be 4 multiplied by 2 will be 8. Okay, this u of 2 and u of 1 will be again 1, right, as per the unit step sequence, right? So it will be simply 20k, right? That is 20k is equals to 24, right? So k is equals to 24 by 20, right? So it will be 6 by 5 simply. So the value of k is 6 by 5, right? So if you are substituting n is equals to 3 in this equation, right? So you will get same value of k, that is 6 by 5. Now you have to substitute this value of k in equation of particular solution. Okay, so whatever particular solution that we assume here, right? So I will say it as in this simply indicating it. So you have to substitute in this particular solution, okay, in equation of particular solution, okay, that is yp of n, okay. So your yp of n will be, so you have to substitute k is equals to 6 by 5, so it will be 6 by 5 n, okay, 6 by 5 n into 4 raised to power n u of n, 4 raised to power n u of n, okay. So that is the required particular solution. Next you have to write down the total solution, okay. So here you can simply say that the total solution of the given difference equation, that is y of n is equals to yh of n plus yp of n, okay. So that y of n will be, what is the value of yh of n? So your yh of n is c1 4 raised to power n plus c2 minus 1 to the power n, okay. So c1 4 raised to power n plus c2 minus 1 to the power n, right? Now what is the value of yp of n? Yp of n is 6 by 5n plus 6 by 5n, right? 4 raised to the power n u of n, okay. So that will be your y of n, okay. So you have to again solve this equation. We'll call this equation as 4, but okay, so I have to solve this equation as well as equation 1, okay. In equation 1 and equation 4 I have to substitute values of n is equals to 0 and 1 to get the values of c1 and c2, and after substituting these values of c1 and c2 in this equation, I will call this equation as zero state response, okay. We have to identify now zero state response, okay. So for finding the values of constant c1 and c2 and the and to to determine zero state response. Okay, substitute n is equals to 0 and n is equals to 1 in equation 1 and equation 4, right? So if I am simply writing equation 1 here, okay, by substituting n is equals to 0, so what I will get, so what is equation 1? So if you find equation 1 here, so this is equation 1, so it will be y of 0 minus 3 y of minus 1 minus 4 y of minus 2, right? So it will be simply, for n is equals to 0, it will be y of 0 minus 3 y of minus 1 minus 4 y of minus 2 is equals to. Next, as we are identifying zero state response, so you have to, you will not consider this input as 0. This input will exist, but in place of input x of n, you will be substituting 4 raised to power 0 u of 0, because I am substituting n is equals to 0, plus 4 raised to power minus 1 u of minus 1 will be there, right? So x of n plus 2 x of n, in place of x of n into 2 x of n, I will substitute 4 raised to power 0 u of 0, right? So it will be 4 raised to the power 0 u of 0 plus what is this, 2 into 4 raised to the power 0, sorry, 4 raised to the power 0 minus 1 and u of 0 minus 1, right? Because I am substituting 0 here in place of n. Okay, so it will be 4 raised to the power 2 into, okay, 2 is there in the equation, 2 into 4 raised to the power 0 minus 1 u of 0 minus 1, okay. 4 raised to the power 0 minus 1 u of 0 minus 1, 0 minus 1, okay. So as we are identifying zero state response, so these initial states will be 0, that is y of minus 1 and y of minus 2 will be considered as 0. So if you are substituting this 0, so you will get simply y of 0 is equals to, because y of 0 will exist there, right? But to identify zero state response, these initial state y of minus 1 and y of minus 2 will be considered as 0. Okay, so y of 0 is equals to 4 raised to power 0 is 1, u of 0 is 1, so it will be 1, right? And 2 multiplied by 4 raised to power minus 1 will be there, but here it is u of minus 1, u of minus 1 is 0. Okay, so as u of minus 1 is 0, so this term will be 0. So you will get this equation y of 0 is equals to 1. So we will call this equation as first equation, just for example. Similarly, you have to substitute n is equals to 1 in the first equation. So if I am substituting n is equals to 1 in that equation, so it will be y of 1, right, minus 3 y of 0, right, minus 4 y of minus 1 will be there, right, is equals to, again I am substituting n is equals to 1, okay, so it will be 4 raised to the power 1 u of 1, right, plus 2 into 4 raised to the power 1 minus 1 will be 0, right, and u of 1 minus 1 will be again 0, right? So what I will get here, so it will be simply y of 1, right, minus 3, what is the value of y of 0? Y of 0 is 1, so if I am substituting y of 0 1 here, so it will be simply minus 3. I am substituting n is equals to 1 in the first equation, okay, so n is equals to 1, I have substituted in the first equation, so it will be y of 1 minus 3 y of 0 minus 4 y of minus 2 is equals to 4 raised to the power, because x of n is 4 raised to power n u of n, so it will be 4 raised to power 1 u of 1 plus 2 into 4 raised to power 0 u of 0 will be there, right? So that thing I have written here, okay, correct. So it will be minus 3 y of 0 is 1, okay, and y of -1, again it is initial state, so this initial state will be considered as 0 for identifying zero state response. So it goes to, so it will be 4, okay. U of 1 is 1 plus 4 raised to power 0 is 1 plus 2 multiplied by 2 will be there. U of 0 is again 1, so it will be 2, right? So what value I will get here? So y of 1 is equals to 4 plus 2 is 6, right? And if I'm sending 3 on right hand side, so it will be plus 3, so y of 1 is equals to 9 I will get, right? Right, so I will get y of 1 is equals to 9, right? So this 3 value I will be sending on the right hand side, so I will get y of 1 is equals to 9. So this is, I'll call it as second equation. So similarly I will substitute n is equals to 0 and 1 in equation 4, okay, in this total solution equation, right? So your fourth equation, after substituting n is equals to 0, you will get c1 4 raised to the power 0, right? c1, that is y of 0 is equals to, you will get simply y of 0 is equals to c1 4 raised to the power 0, right, plus c2 minus 1 to the power 0, right, plus 6 by 5 multiplied by 0, right, 4 raised to the power 0 u of 0, right? So simply you will get y of 0 is equals to c1 plus c2, right? So I'll call this as equation 3. Similarly I will substitute n is equals to 1 in this fourth equation, so what I will get, y of 1 is equals to c1 4 raised to the power 1 plus c2 minus 1 to the power 1 plus 6 by 5 multiplied by 1, right? 6 by 5 multiplied by 1, 4 raised to the power 1 u of 1, 4 raised to the power 1 u of 1, okay. So simply I will get y of 1 is equals to 4c1 minus c2, right? 4c1 minus c2 plus this 6 multiplied by 4 will be 24 by 5, right? This u of 1 is 1, so 24 by 5. So I will call this as equation 4, okay. So to get values of c1 and c2, equate equation 3 with equation 1 and equation 4 with equation 2, right? So if I'm equating these two equations, that is c1 plus c2, I will get c1 plus c2 is equals to, so 3 with 1 I am equating, so first equation is having one value, so c1 plus c2 is equals to 1 I will get, okay. And if I'm equating this fourth equation with third one, okay, so sorry, second one, so I'll get 4c1 minus c2 plus 24 by 5 is equals to, with the second equation it is 9, so 9 will be there, okay. So simply I will get 4c1 minus c2 is equals to 9 minus 24 by 5, right? So 9 I will be performing this subtraction, 9 minus 24 by 5, correct? So so here I will get, simply I will get 21 by 5, right? So if I am writing 9 minus 24 by 5, so after subtracting these two values, so I will get 21 by 5. So this is the second equation, that is 4c1 minus c2 is equals to 21 by 5. So I will simply add these two equations. So again this c2 will be 0, so it will be 5c1 is equals to this 21 by 5 plus 1 will be simply 26 by 5, correct? So what will the value of c1? So if I'm setting this 5 on right hand side, so your c1 will be equals to 26 by 5 multiplied by 5 will be 25. So 26 by 25 value you will get of this c1, right? So similarly this c1 value you can substitute in this equation to get the value of c2. So your c1 is 26 by 25. Okay, so if I am substituting this value in this equation, okay, in place of c1, so I will get c2. So c2 is equals to what I will get. So 1 minus, I am sending this on the right hand side to 1 minus 26 by 25. 26 by 25. So what I will get simply minus 1 by 25. So that will be the value of c2. Okay, so c2 is minus 1 by 25. This will be the value of c2. So substitute values of c1 and c2 in equation 4. Okay, so you will call this equation 4 now as zero state response. Okay, yz of n. So this is your equation 4, right? In place of c1 c2 you will be substituting these values. Okay, so what is the value of c1? So it is 26 by 25. So 26 by 25 multiplied by 4 raised to the power n multiplied by 4 raised to the power n plus, simply it will be minus simply because the value of c2 is minus 1 by 25. So instead of plus I will write minus 1 by 25, right? Minus 1 to the power n, okay. Minus 1 to the power n. Next one is plus 6 by 5 plus 6 by 5 n into 4 raised to the power n u of n. 4 raised to the power n u of n. Okay, so this is the required zero state response. Okay, and finally we have to write down the total response. Okay, so the total response of the given LTI system or discrete time LTI system is, it is y of n is equals to y z of n plus y z of n, that is zero input response plus zero state response. Therefore y of n is equals to, what is the value of y z of n? So that we identified here. Okay, so 16 by 5 y of minus 1, 16 by 5 y of minus 2, 4 raised to the power n. Okay, so it will be 16 by 5 y of minus 1 plus 16 by 5 y of minus 2, right? 4 raised to the power n, right? Similarly minus 1 by 5 y of minus 1 plus 4 by 5 y of minus 2, minus 1 by 5 y of minus 1 plus 4 by 5 y of minus 2 into minus 1 to the power n. Okay, that is zero input response, and the zero state response is 26 by 25. 26 by 25 4 raised to the power n minus 1 by 25. So the zero state response 26 by 25 4 raised to power n minus 1 by 25 minus 1 to the power n, right, plus 6 by 5 n into 4 raised to the power n u of n. Okay, so this is how you are identified the total response of the system. Okay. This is for n greater than or equals to 0. This is the required total response of the system. Okay. So what we have seen in today's session, so initially we have been provided with the difference equation, second order difference equation, and the input signal, right? From given input output difference equation, we identified the homogeneous solution. As it is the second order difference equation, we have identified two roots of that polynomial. Okay, from that we have written the homogeneous solution, right? From homogeneous solution we identified the values of constants and substituted in the homogeneous solution to get the zero input response, right? After identifying zero input response, we have written the equation for the particular solution. But you have to compare, okay? Always you have to compare this particular solution with the homogeneous solution. And after comparison, we find here that the particular solution is redundant, right? It comprises same term as contained in the homogeneous solution, that is constant multiplied by 4 raised to power n is also present in the homogeneous solution. So we have modified the particular solution, we have multiplied it with the time variable, that is small n. Okay, and after modifying it, we have substituted in the given input output difference equation. After substituting it in the given input output equation, we identified the value of k. Okay, so we have substituted this value of k in the particular solution, okay, to get the actual particular solution. Then we have combined this particular solution with the homogeneous solution to get the total solution. From that total solution, again we identified the values of constant c1 and c2. We substituted these values of constant c1 and c2 in the total solution equation to get the zero state response. And finally, we have combined the zero input response and zero state response to get the final total response of the system. Okay. So in next session, we'll be discussing the impulse response of a linear time invariant system. Okay, so that topic we'll be discussing in the next session, that is the impulse response of a linear time invariant system. Okay, most probably a recursive system. Okay, that topic we'll be discussing in the next session. Thank you for joining this session.